Good afternoon, my YouTube viewers. This particular video, we're going to be talking about the Wilcoxon signed rank test, which is another non-parametric test. And what this does is it compares the medians of two dependent samples. So we're going to write a program in Python to perform this test. But before we write the program in Python, we're going to need to import some libraries. So the first library that we're going to import is NumPy as NP, which is a numeric library that also creates NumPy arrays. We're also going to import Pandas as PD, which is a data processing library that creates data frames and series. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And then we're going to import scipy.stats, and we're going to import the Wilcoxon function from that library. Now, scipy is Python's scientific library, and stats is the statistical module within scipy, and Wilcoxon is a model within the statistical model. So what we're going to do is we're going to simulate paired data. We're going to simulate some before and after measurements. So the first thing that we want to do is we want to set our seed. And what happens when you set your seed is that every time you run the program, it initializes to the same values. And that's why you set your seed. So you set the seed by typing np.random.seed, and you can put any number that you want within the brackets. And then we're going to define the variable before, which is np.random.normal, brackets 50, 5, 30. So basically that's telling you that it has a mean of 50, a standard deviation of 5, and a sample size of 30. And then you have the variable after, which is this 4 plus np.random.normal, brackets 2, 3, 30. And that's, so now what you have is you've got your before variable and you've got your after variable. And if you'll notice that the after variable is dependent upon the before variable because it has before in its. So now we're going to perform the Wilcoxon signed rank test. Stat, p-value equals Wilcoxon, brackets before, after, alternative equals two-sided. And then we're going to print the results as being the Wilcoxon signed rank test statistic and the p-value. So we'll come over here. So the test statistic is 98 and the p-value is 0.005. So it's great. It's less than 0.05. So that means the null hypothesis would be rejected if we were testing for a null hypothesis. And now we calculate the pair differences. So differences equals after minus before. And then we create a data frame for visualization. So data equals pd.dataframe, brackets, curly brackets, index equals np.arrange, brackets 1, len before plus 1, before colon is before, after colon is after colon, and differences is differences. And then so we plot the pair differences. So plt.figure, brackets fig size equals 6, 4. And then we're going to make a bar chart. plt.bar, brackets data, square brackets index, data, square brackets differences, color equals blue, alpha equals 0.7, label equals differences after minus before. And then we're going to put a horizontal line on the chart. So plt.axh line 0, brackets, 0, comma, color equals red, comma, line style equals dash, comma, label equals 0 difference. And then the title is paired differences in measurements. The X label is paired observations. The Y label is differences, brackets, after or minus before. You get a legend. And your grid is axis equals yes, comma, line style equals dash, comma, alpha equals 0.7. So you get a code to annotate the differences on the bars. And then we're going to plt.type layout and plt.show. So this is the paired differences measured. You can see the 0 difference is your red dashed line, and the differences are of after and before. And so you can see some of the differences are positive and some of the differences are negative. But you can see that you have more positive differences than you do negative differences. So that concludes this video. The next video, we're going to discuss another nonparametric test. So I hope that you decide to watch it.